Welcome to this explainer, where we're going to dive straight into the Cambridge Mathematics exam strategy and get right inside the examiner's head. Whether you're navigating the core foundations in Syllabus 0580, tackling the advanced concepts in 0606, 4024, 4037, 4040, or stepping into the heavy-hitting A-Level 9709, you know that mastering the mechanics of how to actually answer a question is the absolute bedrock of your success. Today, we're zooming in on mechanics, specifically friction and limiting equilibrium. But here's the massive challenge we need to address right out of the gate. Every single year, thousands of students walk into that exam hall, stare down a complex mechanics problem, and completely miss what the examiner's actually asking for. I want you to picture two typical students sitting their paper right now. First, we have Alex. Now, Alex is incredibly smart. Alex has memorized literally every single formula in the textbook. When faced with a mechanics problem, Alex just overloads the page with raw mathematical facts. We're talking every equation for velocity, forces, and friction, splattered across the page, but with absolutely zero structural analysis. It's just a data dump. Then we have Sam. Sam genuinely understands the physics, but Sam is completely panicked, racing against the clock. Sam rushes through the paper, completely missing the crucial command word requirements hidden in the text, and just writes down numbers without any clear method or logical flow. Both of them walk out of that hall feeling pretty confident, and both of them are going to lose heavy marks when the red pen hits their paper. They'll be looking at a page bleeding red ink, wondering where it all went wrong. Today, we're going to look at their flawed approaches side by side with the examiner's actual mark scheme, and we're going to show you exactly how to transform those red marks into green check marks. We are building your ultimate mathematical success blueprint.
Now, what's really interesting about this number right here is that the specific topic of friction, specifically the equation F equals mu r and the concept of limiting equilibrium, accounts for approximately 15% of your total Paper 2 marks in the mechanics modules. Think about that for a second. 15%. That is literally the difference between an A and a B or a B and a C. It is a massive chunk of your overall grade concentrated into a very specific set of interconnected principles. You absolutely cannot afford to just have a basic, surface-level understanding of this topic. You need to master it with the ruthless precision of a senior examiner. When we analyze the principal examiner reports, they consistently point out that students are leaving all these marks on the table because they treat mechanics as a test of memory rather than a test of logical, step-by-step reasoning. They don't know how to decode the command words. Before we really get into the weeds here, I want to introduce you to the framework top students use. It's called PEAL: Point, Evidence, Explanation, and Link. Now, you might think PEAL is just for English or history, but no, it is a game changer for Cambridge mathematics. Your point is your opening mathematical statement. Your evidence is the formula you select, like F equals mu r. Your explanation is your working out, clearly annotated. And your link is tying that final numerical answer right back to the specific physical scenario in the question. Alex and Sam, they aren't using PEAL, but you are. Before we continue, subscribe to our YouTube channel Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's decode exactly how you can capture every single one of those percentage points.
To secure those marks, we've structured our explainer today into 4 crucial parts, acting as your ultimate study roadmap. First, core principles. Second, the method mark strategy. Third, examiner warnings. And finally, evaluative thinking.
Okay, let's dive into Section 1, Core Principles, and build that rock-solid theoretical foundation you need to succeed.
The entire theoretical architecture of mechanics rests on your understanding of this exact state and how it connects to the rest of your syllabus. Limiting equilibrium is not just a vocabulary term you memorize, it is a critical physical threshold. It is the exact microscopic moment right before an object begins to slide. At this precise state, and I mean only at this precise state, the frictional force F reaches its absolute maximum possible value, which allows us to actually use the equation F equals mu r. One of the biggest mistakes our student Alex makes is scanning the page, seeing the word friction, and immediately writing down F equals mu r, completely regardless of whether the system is actually in limiting equilibrium. If a heavy block is just sitting on a rough plane, perfectly still and nowhere near slipping, the friction is simply balancing the forces acting down the plane. It is not at its maximum. So if you use F equals mu r there, you've completely failed the logic test. By relying on precise definitions and establishing correct causal relationships, you avoid falling into this classic trap. You must mathematically prove the threshold has been reached before you deploy the formula. If we apply the PEAL framework here, your point is stating whether the object is in limiting equilibrium based on the text. Your evidence is setting up the inequality or equality. That is what examiners want to see.
And this brilliantly illustrates a key insight from the principal examiner reports. We see that students who integrate concepts across topics score significantly higher than those who just list isolated facts. The examiners are practically begging candidates to show cross-topic connections. For instance, when you establish limiting equilibrium, does it just stay a statics problem? No way. Often it transitions immediately into dynamics. A force increases, that delicate equilibrium is broken, and suddenly you are using Newton's second law, F equals ma, to find acceleration, which then links straight into kinematics. Now think back to Alex. Alex treats statics, dynamics, and kinematics as completely separate chapters in a textbook. Alex's brain is highly compartmentalized. But top candidates, they see them as one continuous flowing story. When you can seamlessly move from resolving forces to finding an acceleration value, and then dropping that exact value into the equations of motion to find the final velocity of a particle sliding down a plane, you are demonstrating the exact structural reasoning the examiners are desperate to reward. So let's initiate the transformation right now. Imagine we give Alex and Sam a 60-second timer to rewrite their flawed answers. Alex needs to stop the data dump and write one clear, connected chain of equations. Sam needs to stop rushing and actually label which direction is positive. It's about changing the fundamental approach from frantic calculating to strategic demonstrating.
The assessment framework is testing these distinct cognitive domains, meaning superficial breadth will always lose out to deep analytical reasoning. You cannot just shotgun formulas onto the page and hope one of them miraculously hits the mark. First, you must target knowledge and understanding by showing you know the physical conditions for limiting equilibrium. Second, you demonstrate practical application by setting up your equations correctly, like explicitly resolving your forces parallel and perpendicular to the incline. Finally, you prioritize analytical depth by solving those equations systematically and interpreting what your final answer actually means within the context of the physical system. It's a tactical, multi-step process, and you need to operate on all three levels to secure full marks. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Let's move to Section 2, the Method Mark Strategy. This is the absolute core of our exam workshop today.
Examiners award incredibly valuable method marks for process, so you must strictly adhere to this 4-step procedural framework when presenting your workings. Think of this as your ultimate safety net. Step 1. Write proper headings. Before you write a single number, literally write out resolving forces vertically or taking moments about point A. Step 2. Use correct terminology. Don't just scribble an R, specify it as the normal reaction force. Step 3. Apply appropriate formats. Keep your workings linear and highly logical. Step 4. Provide clear annotation. If you are substituting equation 1 into equation 2, write sub 1 into 2. Okay, it's time for our first interactive workshop challenge. I call this the data scan. I want you to imagine a complex mechanics data table right in front of you. You have a 60-second visual countdown timer in your head. Your goal is to extract the core trend. Are the frictional forces increasing as the angle of the plane increases? Yes or no? If you can't spot that trend in 60 seconds, you're going to get bogged down in the math. You have to actively scan, identify the parameters, and then apply these 4 steps. Let's do a mental rewrite of Sam's paper right now. If Sam takes just an extra 10 seconds to write down resolving parallel to the plane, force minus friction equals 0, and explicitly defines friction equals mu r because the particle is in limiting equilibrium, he instantly secures the method marks. Even if his hand slips on the calculator and he writes the wrong final value from you, the examiner sees the logic, sees the annotation, and awards those M marks. That is how you play the game and win.
Your practical data interpretation skills must flow logically from extracting data from tables to drawing concrete, evidence-based conclusions. In complex exam questions, you might be given a table of forces acting at different angles. You must extract that specific data, interpret the relationship, perhaps noting that as the angle of the incline increases, the normal reaction decreases, meaning the maximum frictional force also decreases, and finally conclude what that means for the equilibrium of the particle. Following this logical, unbreakable flow of extract, interpret, and conclude ensures that your evidence-based conclusions are completely bulletproof. It's the Peel framework in action again.
Now it's time to uncover the trapdoors by examining our third section, direct warnings from the exact people who mark your papers.
These are the top 3 mistakes highlighted in the principal examiner reports that consistently cost students their grades when they are under pressure. Okay, workshop challenge number 2, find the flaw. I'm going to give you a flawed sample paragraph, and I want you to identify the sentence that is hemorrhaging marks. Listen closely. A student writes, because the coefficient of friction is 0.5, the block must be sliding down the plane. I resolved the forces and found the weight. What is the flaw there? Take a couple of seconds to really think about it. Got it? They are completely confusing cause and effect. The coefficient of friction mu is just a physical property of the specific surfaces. It does not cause motion. The cause of motion is the component of the block's weight pulling it down the plane, overcoming that maximum frictional force. That is a massive conceptual error. Warning number 2 is forgetting presentation conventions. Like we discussed with Sam, not annotating his force directions. If an examiner cannot tell which direction you consider positive or negative, they cannot follow your logic, and they absolutely cannot give you method marks. Warning number 3 is the most insidious, providing generic answers. If a question asks why a specific 5-kilogram crate topples before it slides, you cannot just write a generic definition of moments. You must calculate the exact moment for that specific crate.
So, the crucial point you must take away from this explainer is this exact examiner alert. Never ever leave an answer disconnected from its context. This brings us to workshop challenge number 3, speed writing. Imagine a 30-second timer counting down right now. You need to write one perfect Peel paragraph. The question asks, explain mathematically why the particle comes to rest. A generic answer is simply writing, because of friction. 0 marks. But a top-tier, deeply contextual answer relies on the math. It sounds exactly like this. The particle comes to rest because resolving forces parallel to the plane shows the rough surface provides a calculated maximum frictional force of 12 newtons. Using F equals ma, this specific force creates a constant negative acceleration of -3 meters per second squared. Applying the kinematics equation v squared equals u squared plus 2as proves that this exact deceleration brings the velocity to exactly 0 over the given 4-meter distance. Boom! Do you see the difference there? The second answer leaves absolutely no room for doubt. It uses mathematical evidence locked directly into the specific scenario provided by the examiner. That is what a perfect Peel paragraph looks like in mathematics.
Let's bring it all together in our final section, evaluative thinking, to master the highest order skill required for those top-tier marks.
Top-scoring candidates operate at that evaluative tier by considering different perspectives, identifying differences alongside similarities, and backing up absolutely every decision with hard evidence. Let's break this table down into our final mathematical system. At the descriptive level, you are just identifying the basic forces. Weight acts down, normal reaction acts perpendicular. It just shows basic understanding. At the analytical level, you are using structural reasoning and mathematical connectives. You calculate that the component of weight down the plane is greater than the maximum possible frictional force. But at the evaluative level, the higher order logic tier, you are actively questioning the mathematical assumptions of the model. You look at a problem and ask, wait, is this particle actually acting as a point mass? Does air resistance factor into this specific model? Is this string actually light and inextensible? When an exam question asks you to evaluate the assumption that the pulley is smooth, you must justify with mathematical evidence what would happen if it wasn't, namely that the tensions in the string would no longer be equal on both sides, which completely changes your simultaneous equations. Moving from descriptive calculation to evaluative justification is the final step. So here are the 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, strictly applying the PO framework. And Rule 3, operating a time management matrix where you don't rush like Sam, but you also don't overcomplicate like Alex.
As we wrap up this explainer, I want you to look back at your own recent past papers. Be honest with yourself. Are you writing like Alex, just dumping raw formulas onto the page without any structural logic or a clear path? Or are you rushing like Sam, losing vital, easy method marks because you won't take 5 seconds to write resolving vertically? To truly ace this exam, you need to evaluate your own answers, apply the strategy we've built today, and keep mastering those cross-topic connections. So ask yourself, are your answers generic or are they deeply contextual? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep questioning, keep practicing, and we'll see you in the next session.